All right. Here we go. Function operations. So we have two functions. We have f of x and we have g of x. So what you're going to do is you're actually going to take those two functions and you're going to perform some operations on them. No, not surgically. So f of x plus g of x. The only thing we're asking you to do here is to take function f, 2x plus 3, and add it to function g, x squared plus 5. And this is as simple as combining like terms. So we have x squared, 2x plus no other x's is 2x, 3 plus 5 is 8, and you're done. That's it. This is multiplication, but this is f of x times f of x. So that's a 2x plus 3 times 2x plus 3. As you know, this is just foiling. So you're going to get 4x squared plus 12x plus 9, and you're done. That's it. Leave it alone. Next example. That's g of x minus f of x. So we're going to take our x squared plus 5, and we are going to subtract f of x, 2x plus 3. Distribute the negative. That's going to give you x squared minus 2x plus 2. That's it. Now going down the right side, that's called a composition of functions. So what we're going to do here is we're going to color coordinate these for you. So we're going to have, we'll call f of x purple, and we'll call g of x green. And what we're going to do here is we're going to insert the g function into the f function. So whenever you do substitution, you know you plug it into the x. So this is going to start with, since g is going into f, it's going to start with a 2, but then once we get to our x, we just open up some parentheses. And then we finish writing the entire f equation. But now what we're going to do is we're going to substitute g into just the x of the f function. So now all you have to do is distribute, and that's going to give you 2x squared plus 10 plus 3. Combine your like terms, and you get 2x squared plus 13, and that's it. You're done. It's not a difficult concept. It's just a little bit different. So in the next example, we're going to substitute the f function into g. So the first thing we're going to do is already get to our x, but then that's squared plus 5. And now we're going to substitute in our f, 2x plus 3, into just the x of that function. And again, all you're going to do is FOIL this, so that's 4x squared plus 12x plus 9 plus 5, combine all your like terms, and you get 4x squared plus 12x plus 14, and you're done. So the last one is f of x. So what you're going to do for this is start writing your f of x, but give parentheses. And now you're going to substitute the f of x right into it. And then, you guessed it, you're just going to distribute 4x plus 6 plus 3, and you get 4x plus 9, and that's it. You're done. So that is composition of functions. Let's take it further. Now let's get into some that are a little bit trickier. So we have m of x, n of x, and t of x. So why do these get a little bit trickier? Just because of what these actually are. So we have 2x to the 1/2 power times 4x to the 2/5 power. No big deal. 2 times 4 is 8. And then x, so, oh wait, what are you going to do here? You got to remember those rules about adding exponents. So, of course, what you're going to need to do is change that to a 5/10. And this is going to have to change to a 4/10. So this is x to the 9/10. And you know you're not allowed to have a fraction exponent, so you must rewrite this as 8 to the 10th root, or times the 10th root of x to the 9th power. All right, so that's what you need to do for those. The one below it, that's m of x, so 2 times x to the 1/2 divided by 4 x to the 2/5. So you're just going to have to subtract, and you're going to end up with 1 over 2. So it's 2 over 4 reduces to 1/2. And that's going to give you an x to the 1/10 power on the top. Of course, we'll rewrite that for the 10th root of x over 2. That's how you simplify. And then, of course, you have your compositions. So we're going to take m of x and insert it into n. So we have n, which is 4, and then here's our x to the 2/5 power. And then we're going to insert m into it. So that's going to be our 2x to the 1/2. So now you have to raise everything to the 2/5 power, which is inside. So that's going to bring you to 4 times 2 to the 2/5 power times x to the 2/10 power. So what are you going to do with that? Well, this is going to become 4 times. You want to rewrite this so it has the same base or denominator for your exponent. So this is times 2 to the 4/10 x to the 2/10. So you can rewrite that as 4 times the 10th root of 2 to the 4th power and x squared. So what are you going to do with that? Well, 2 to the 4th power we know is 2, 4, 8, 16. So 4 10th root of 16 x squared. And let's see, do you think you can simplify that anymore? You actually can. Remember, this is a 4, so that can be reduced to a 5th, and that's a 2, so that can be reduced to a 5th. So final answer is 4 5th root of 4x. Yep, I know, it's tricky, a little confusing, but we'll get through it. Last example, t is going to take in n, so we have 6, and then we have our x to the -2. And we're going to put n inside. That's 4 x to the 2/5. And that's going to flip it. So this is going to become, make a little more room, 6 over 4x to the 2/5 squared. Because that negative just took the reciprocal of just the parentheses. And that's going to become 6 over, that's going to give you 16 x to the 4/5. We're going to rewrite that. So 6 over 16 we know is 3/8. And then the 5th root of x to the 4th. Not allowed to have a radical in the denominator. So that's going to become 3 over 8x. And then that's because we're going to multiply the top and bottom by the 5th root of x. And there goes your final answer with that. So that's it. That's how you use all of these to take compositions of functions. Now I'm going to tell you what we're also going to start doing is listing domain. Domain and range. So a little sneak peek into domain. Domain is always real numbers unless you have a few issues. First of all, even roots. Remember, you can never take the even root of a negative number. But you can take the odd root of any number. And also remember, the denominator is never allowed to be 0. So a couple quick examples here. Remember, this is 5 times the cubed root of x. You can take the cubed root of any single number that you want. So the domain of that example is all real numbers. 2 to the x to the 1/4. If we were to rewrite that, that's 2 times the 4th root of x. So you know that x is not allowed to be negative in an even root, so your domain has to be greater than or equal to 0. This right here is already simplified, but you know the denominator is never allowed to be 0. So 3 times 0 would make a 0 down there, so in this case, x is not allowed to be 0. And in the last example right here, again, the denominator is never allowed to be 0. So if we put a 0 here, that'd be okay. 2 times 0 is 0 plus 4 is 4. That would just reduce to 1/2. But if x was a -2, that would be a problem. So when you have something bigger in the denominator, you would just set it equal to 0 and solve. So x cannot equal a -2. So we're going to be doing more examples with domain in the very near future. But for now, that's it. This is Longo and I'm out. See you, bye.